happy to introduce our next speaker, Mona Jimenez, who started transferring obsolete videotapes in the late 1980s and has been an advocate and organizer for the preservation of independent media and media art ever since. She is Associate Arts Professor and Associate Director in NYU's Moving Image Archiving and Preservation Program, where she teaches the preservation of video and digital works. She is co-editor with Sherry Miller-Hocking and Kathy High of The Emergence of Video Processing Tools, Television Becoming Unglued, which documents collaborations between artists and technologists to create custom tools for media art. Since 2009, Mona has been experimenting with participatory models of media and film archiving locally and through community archiving workshops organized by the Independent Media Committee of the Association of Moving Image Archivists. She is the founder of Audiovisual Preservation Exchange, a project to network audiovisual archivists, educators, and students internationally through shared work on collections. Mona will be speaking on the anatomy of the artwork, Dissecting Software-Based Art. Please join me in welcoming Mona Jimenez.
Hello. Well, I'm going to be talking about materialities. And then we'll have lots to talk about in terms of negotiating materialities. I was really happy to hear that, intrigued by Christian's comment on that matter. Before I start, I just want to say that a thank you to MoMA and say that MEUP has had a long-standing relationship with MoMA. And two of the works I'm going to be talking about, or three of the works I'm going to be talking about are in the collection, which you will see through the captions. And two of them were part of my Handling Complex Media class. Students were examining those as part of that class. And also, one of them was part of a computer working group project that was organized by Glenn Wharton at NYU. And so, but I did want to say that I'm not really talking about the status of the works because some of them were examined quite a long time ago, like the CPU that we're going to be looking at was in 2008. So I'm not talking about the way, what actions have been taken by MoMA, just using them as examples where we can see some of those materialities. So, and also I want to say that in my classes and in thinking about this presentation, I rely heavily upon Pip Lawrenson's 2007 essay called Part 1, Risk Assessment, From Inside Installations, Preservation and Presentation of Installation Art, which was published by the Foundation for the Conservation of Contemporary Art. So I specifically use some of the terminology that she uses in that article. So what do I mean when I talk about, just gonna get my timer started. What do I mean when I talk about anatomy? So for me, what this means is looking at structure, basic structure, where are things located, where are things happening, and within that, what are the processes that are occurring, and so in other words, what is being carried out, what is being generated, what is really happening in the work. And then the interrelationships or interdependencies that are happening. So that's how are different parts of this work communicating with each other. How are the hardware and software communicating? How are the software and the software communicating? And so on. And the reason that we do this, from what Pip has introduced, is to be able to identify the component parts of a work or the constituent parts, and to be able to understand what their relative value, in Pip's words, their relative value. So in other words, what are the parts that are important to and that impact the significant properties of the artwork that make that work what it is? And then how might they have varying importance in terms of meaning and functioning and so on? And so this is, a few significant properties that you might find in works that you hold. And so I just want to say for aesthetics, and if we're talking about materiality, that the things like color, space, resolution, aspect ratio, those just be a few of the things that might impact a look and feel. And obviously, there's a lot that have to do with behaviors and interaction and timing and so on. So what Pip then says is that we should project, once we have some understanding of these component parts and their relative value, we should think about future scenarios. So unfortunately, that's not a rosy picture, you know, it's sort of looking at where might failures happen, where might things change that are going to cause problems, and so on. So some of the issues that might, these works might be facing. So I want to say just a little bit more about software, since this is a software-based art that we're talking about, and what role software has in the functioning of work. So software, you know, executes, as I said, and directs processes. That's why we care so much about finding out where it is. And it also controls and integrates and manages hardware and peripherals. So there's this, again, this kind of communication that's happening, and that is software is instructions, and those instructions are written in code. So, you know, we know many of these already. We have common sense in daily practice where we're dealing with these issues, where we're seeing software being executed, and where we're dealing with the issues that I mentioned in the slide before. And we've talked a lot about source code in the next few days, and so I wanted to just give us some definitions of that. So as Mark explained, that the CPU has to understand, the hardware has to understand what you want it to do in machine language. But we have evolved these computer languages which allow us to write code in a human-readable form, and also to create libraries and routines that will be stored in libraries that can be accessed, so that not everything has to be written out, so that you can actually, you know, address or refer to some routines that are already written. So, and then when that human-readable code is written, it needs to be translated back so that the computer knows what you want it to do. And so there are two things that we'd like you to be, or two main ways we'd like you to be aware of, and that is using a compiler. So that's compiling the code into, translating it into something that again, the hardware can understand. And then interpreters, which also will do that same kind of translation to machine code, but doing it on the fly. So doing it not as something, we'll see some executables in the next few examples. So those would be compiled. That's something more that you launch, right, as opposed to something that's being done in real time. So they can be open source or proprietary. We'll see that there may be complications there because there may be proprietary libraries, for example, that some kind of open source code might address. And also you can see that there's degrees. So some are as Mark was saying, like C++, very well documented processing as a development environment and things like that. But others are less well known and more problematic. I want to first talk about Michael Joaquin Gray, Perpetual Zoz, and Adana and Child, which he defines as a computational cinema. And I'll play a little bit to help you understand the work. Is this from YouTube, so it doesn't look so beautiful? Assuming you recognize some of the figures in there. So, how does Perpetual Zoz work? Well, it's an object has been made, a plane, and on either side of that plane, video files are playing. In addition to that, there's a soundtrack, or I should say an audio file, which is a compilation of the heartbeats of the artist and his mother, and also apparently there's, in the audio track, a few of the clock sounds from Pink Floyd's Dark Side of the Moon. So the video is obviously, it's the Wizard of Oz. It's playing forward on one side, and going in the other direction on the other side. And as it's moving, the sound is mapped to the luminance values of the video. So what I mean by that is when the amplitude of the sound changes, that is directly mapped to some luminance value. So you have that dimensional change occurring as the sound changes, and the dimension, so that the particular value, whatever along the grayscale, will cause that to rise. This actually, I was talking with Mark beforehand, is not a great slide but I'm going to explain that this is, you may remember that Mark talked about the visual programming language that is present in the software called Max MSP. And this is actually, Gen and Max is actually a different part of the program, not the part that was used by the artist. And the programmer, I should mention, is R. Luc Dubois. But you can see the boxes again, this kind of idea working right to left, that different instructions are being made to make the work function. So if I look at this, I think about the different parts that are involved in this work, I come up with some of these. And again, at the top, I'm kind of reiterating a little bit about what's happening in terms of action. Very important that the artist explained is that the duration of that rotation of the plane and the running of the video and the audio are not synchronized. So it's not a linear, start to finish. Every time that plays, it plays slightly differently. So those relationships are slightly different. And it was made in a program called Max MSP Jitter, and it has the executable is a patch, which is called a patch, and it's in that format that you see up on there. And that creates these instructions to the objects that are part of the Max program and tells it to do, have those objects do certain things. And so that's and it runs in, so the production program is Max MSP Jitter, and it runs in this runtime application, Max MSP 5. So these objects are not accessible. We don't have the source code for those objects. And there is a Mac Mini, but it doesn't have much of an impact at this point on the work. So if I look at that, what I call characteristics, if I think about those component parts and sort of their relative value, I've listed these and called them characteristics. So the artist is not interested in the particular software that was used for this work and feels like it could be executed under different software. But the patch is written and plays in proprietary software, as you can see. So the code is not available, and we have to be reliant upon a company that, as Mark indicated, is perhaps undergoing change. And the file formats are proprietary. They're QuickTimes. And I didn't have access to that, so I'm not sure what codecs they're using. It's a proprietary format, QuickTime, and I don't know how sustainable those will be. But then again, we do have this visual programming language that helps describe the objects. And the programmer was really, in an interview that was done with him, he really said, I think these are really well documented. And when talking with Mark yesterday, we said, they could be rebuilt. And this is not a complicated piece. It only has 3 pieces of media, and it has a script that probably is pretty understandable. So just in contrast to that, this is actually the Internet Archive's a site where you can download Laurie Anderson's Puppet Motel, which was made in 1995. It was a CD-ROM made in a program called Macromind Director, which Mark also mentioned. Interestingly, they've made a disk image and uploaded it so you can download it. And presumably, if you could get it back on an optical disk, because it needs the disk to run, or at least in the old way, that you could actually run this. So interesting, so what this work was a series of 33 rooms that you would navigate by, mousing over areas which were not, where you had to find the areas, and it would take you to different rooms. Very nonlinear, very interesting work, and I hope somebody's collected it. And incidentally, you can see that the programmer was Chen Huang, and this information is from his website. So when I take a look at this in my my old Mac running System 10, one of the early System 10s. You know, it's interesting what we find. So we find that there is a folder, and also there's some documentation that tells you what systems requirements are and how to put it onto your computer and so on. But what we find is described application, classic, and if you remember classic, that's OS 9 running, you know, in a 10 environment. And then there are a lot of files. If I look at it in a different, if I look at it organized by find as opposed to organized by name, I see at the very top that inter.dr. That is the executable, okay? And and it opens in, it's packaged with the player, so that the player is playing this executable. And there are a lot of files here, which is really interesting. So there are a lot of files, but nowhere near the files that are needed for the work. And what is really interesting about this type of work is you can't really, it's very hard to identify what file goes with what part of the work. And in this case, we don't have access to the script, so it's locked. So it's quite a problem. We can do some really simple things, like if I open and look at GetInfo for the folders and for the work, you see that actually it runs using a director projector 4.0, and that you can see that will give you some clues to the native environment. But it's really a problematic work. Several people have mentioned John F. Simon Jr., and this is CPU from 1999, and it's quite similar to what we saw before, the works that are owned by the Guggenheim. And what's interesting is that a similar work was discussed during the symposium that Christiane mentioned, and that was 2004. And my students interviewed him, and it was interesting to hear him talk about what he thought was important. He basically thinks that the code is the work, but he had also said in the interview that it's very important for the audience to know that it's run on a computer. So he wanted people to be away from the wall so you could look to the back and see what the computer was that, it was not hidden behind a wall, right? So the structures and the parts, if you look at that on this one, again, some issues with some code that's accessible, but also using some proprietary parts. In this way, there's Semantic C is a Mac OS specific compiler, and also the quick draw libraries are a problem, not to mention the whole laptop itself, and that it's maybe a very big job and difficult to recompile. So the last work I want to talk about is I Want You to Want Me, which is Jonathan Harris and Sepp Kambar. In this work, I'll just show you I'll show you the work. And we just need sound for this, please.
I Want You to Want Me is a project that explores the search for love, but also the search for self in the world of online dating.
Every few hours, we pull data from online dating sites all over the world. We put these dating profiles in a database. We do several different movements, and each of these movements explores a different topic. One movement explores who people are, and that's called Who I Am. One movement explores what people are looking for, that's called What I Want. And we allow people to search through them by saying, like, I'm interested in seeing what women in their 20s are like, and I want to see what men in their 60s are looking for.
So I'm actually going to move on because I want some opportunity to discuss this. And this is just another screenshot. So I think from that very beginning understanding, we can know that this pulls data from dating services, collects it somewhere, and then brings it to something. In this case, it's an integrated computer and display. So I thought instead of me describing more about this, that we could actually, I could hear from you about where you think the points are that we need more information about the materiality in order to understand this work. So I was hoping that some people would be brave and willing to come up to the microphone and just state where they think there might be some investigation needed. Please. Those of you who are new to this, please. Okay, some of my students perhaps, or some of the TechFocus committee, or
Understand how the piece is interfacing with those external sources.
so he said you need to understand how the computer is interfacing with those external sources, which is really, yes. And so what kinds of software might be involved in that communication between the work that's being displayed and the database, and where are those databases, and what, again, are the dependencies for getting that information from the internet. And really, what are they? Are they text? Are they image? Can anybody see the different parts in this, other parts? What parts do you think are involved? Yes. Do you want to go up there? Yeah. And then Helen will tell me when it's time to stop.
Yeah, you'd need some way to parse the incoming text for the context. He had different topics, and so some you'd filter completely out because it'd be inappropriate, but others you'd have to find a way to interpret and figure out what category it's going to be placed in.
So what the nature of that database is, it sounds like, too, right? Okay.
Or the individual message.
The individual messages, Okay. Okay, others? Just like a minute more, and then you can ask questions. Not that I know the answers, but I'll get help. Yes, Glenn.
There are also audio and
We're trying to get people to go to the mic, if you don't mind. I know. Takes a minute.
There are also audio and video files.
Yes. Being a video person, I really like to notice those things. So you might not have been able to see them, but within the balloons are video files. And so those are also, as I recall, probably QuickTimes. Again, sustainability issues, proprietary nature of those. And so they're all floating in those little balloons, yeah. Okay, anything else, or would you rather move to questions? Yes.
I think I would be concerned about the computer being integrated in the touch screen. So
Yes.
basically, you have that dependency. And then I would also be interested to know how the specific touch screen technology of that make and model connects to the piece. Whether that would be exchangeable. Could I migrate that to a different piece of hardware, or does my piece die when the hardware, either the computer or the touch screen,
Right,
or
right.
both dies? Yeah.
So there's a lot of complexities in terms of what's stored on the computer and what's not stored on the computer, and Joanna is exactly right. That is a very proprietary system of the hardware containing the computer, basically being integrated. And so finding something that, and the artists have specific ideas about what they would like in terms of that, in terms of dimension, and of course the interactivity is very important. Anything else, or would you like to come up?
So the actual way that the balloons are arranged is something that must be organized in code. And then there's the particular look and feel of the balloons, whether they're actually drawn balloon by balloon or whether they're blatting a sprite onto the screen.
So you mean the text is drawn, like sort of drawn?
Well, it's talking about the actual balloons. They're little balloons.
The
moving
balloons,
around.
yeah.
But yes, the way the text is drawn and things like that,
Right.
those are all animation functions.
Right, so then that, in this case, they actually say it's written in C++. And so, do you program?
Yeah.
Yeah. So, do you want to say anything more?
Well, C++, despite what you've heard here, is not a very portable language. It doesn't have very good standards. Almost all its libraries have variations from compiler to compiler. It's actually kind of a hard problem, I would say.
So I did want to mention that if you can't run that source code, and then it, well, you'll hear more about this tomorrow, but the decompiling of the code will, in some cases, is possible, and then recompiling it because the code is specifically connected to hardware. Did you want to say something? Yeah.
I can't remember now, but in one of the other talks, someone brought up taking data from external sources.
Right.
And I don't really see online dating going away anytime soon, but the nature of it will change, and gender representation or what people are asking for or how they represent themselves, how does that change the piece in the future? Do
Right.
we see it as a time capsule or as like an ongoing discussion of dating?
And we did interview him. I interviewed him, but I actually didn't have access to the interview for this or couldn't quite recall, but I know that there was some discussion about capturing at a certain moment in time, and actually Kate Lewis or someone from MoMA might be able to tell us whether or not that actually has been done in order to mitigate that one external dependency. Yeah.
With the web crawler, is that a custom web crawler? Are they using like an open source project and then kind of modifying it? And then if that project, gets updated or something like that, is it no longer going to work? And is in the future, when these dating websites get updated, is the web crawler still going to actually work?
Right. So, and I don't know if if anybody wants to speak to any of these things, but I think the point is really more to say that these are areas of consideration. So I've been asked to stop, and so I just wanted to say that these are other, some areas that we look to for, I'm turning, I'm not supposed to, areas that we look to for, information sources for analysis, and just wanted to say thank you to all of these people, in addition to Mark Heller, who's spent some time with me in the last week. And the CPU is actually also, Perpetual Zoz was examined by Howard Besser in his class in 2007. So thanks to them. Thank you.